Hi friends, welcome to the next session. Now let us see some issues regarding the process synchronization and the serious problems caused by synchronization, and one of the problems caused is deadlocks, and other is what we call starvation. So just look at this in short now. In future we are going to deal with the deadlocks in more detail and how to solve this problem and all that will be in the coming sessions, but just as a continuity, just look at what this is. So deadlock occurs when a group of processes are stuck forever, each waiting for a resource held by another in the group, and none can proceed. So we have some shared resources and we have some processes. One process catch hold of some resource, another process catch hold of another set of resources, and waiting for the other resources, and those other resources may be held by some other, and because of this it may so happen that none of the process can proceed further. How is this possible? Let's take an example. Assume that we have two processes, P0 and P1, and currently working with two resources, S and Q. So here on the first place, P0 says wait for S, and S was available, so S is given to P0. Same time, P1 requested for Q, Q was available, given to P1. So what has happened? S goes to P0, Q goes to P1. No issue. Next line. P0 says I want Q. Where is Q? Q is with P1. And P1 has to release Q. So to release Q, it has to execute signal Q. But to execute signal Q, it should come forward after wait S. Now what is wait S? It wants to use S. Where is S? S is held by P0. So P0 is holding S, P1 is holding Q, P0 wants Q, which is not available till P1 completes its critical section, and to enter critical section P1 wants S, S is with P0. To complete its critical section P0 wants Q, Q is with P1. So P0 catch holds of S, P1 is holding Q, and if S is not made free, P1 cannot continue. If P1 cannot continue, Q cannot be freed. If Q cannot be freed, P0 cannot proceed. If P0 cannot proceed, then S cannot be released. If S cannot be released, P1 cannot continue. If P1 cannot continue, Q cannot be released. If Q is not released, P0 cannot be continued. So these two are waiting for each other. P0 is waiting P1 to release Q, and P1 is waiting for P0 to release Q, and P0 can release S only when P1 releases it, the releases Q, and P1 can release Q only when P0 releases S, and this is what we call a deadlock situation. So for deadlock to occur, there are four conditions, and all four should be met, and that is what the Kaufman's conditions are. So the first one, mutual exclusion. So only one process can use a resource at any given time. That's one condition that has to be taken care. Yes, all these days we are talking about synchronization and trying to make sure that any given time only one process can use any shared resource, not more than one. So mutual exclusion, because of the uh, process synchronization, we are achieving this. Second thing is, if hold and wait is allowed, that means we have seen in the previous example, the process P0 holds S waiting for Q, and process P1 holds Q and waiting for S. If this was not allowed, if you are not allowed hold one, wait for other, then it would not have happened, because one, any given time, one resource, maximum one process, mutual exclusion. Second, you can hold one resource, wait for other resource, and that other resource may be held by someone else, and there may be some problem, and there is no preemption. That means the process will continue to run as long as it can. There is no stopping from outside. The process has to stop execution by itself after completing its task. There is no preemption. So if preemption is not possible, then from outside we cannot kill any process and release any resource it is reserving. So that's and most important is circular wait. This is waiting for this, this is waiting for this, this is waiting for this, this is waiting for this. So there is a circle here. Each one is waiting for the other to complete, and that makes a circle. Then none of them can complete their work, and hence the whole thing comes to a halt, and that situation is called deadlock. So example, two resources, two processes, two resources R1, R2, two processes P1, P2, and here R1 is assigned to P1 and R2 is assigned to P2. R1 is assigned to P1, R2 is assigned to P2. So fair enough, no problem. But now P1 wants R2. Fine, P1 wants R2, but R2 is assigned to P2, therefore it cannot get, so it keeps in the hold state. Now P2 wants R1, so it waits for R1. R1 is with P1, R2 is with P2, P1 waiting for R2, P2 waiting for R1, and till P1 gets R2, P1 cannot continue, and therefore R1 cannot be released, and till P2 gets R1, it cannot continue, therefore R2 cannot be released. So if you look at it, mutual exclusion, R1 is assigned to P1, therefore P2 cannot get R1, done. R2 assigned to P2, so P1 cannot get R2, done. Hold and wait. P1 is holding resource R1 waiting for R2, P2 is holding R2 waiting for R1. Yes, it is there. And this, if this scheduling is non-preemptive type of scheduling, then this whole thing you cannot stop from outsider. So P1 has to release R1 only after completing its work. To complete its work, it needs R2. So you cannot just from outside, nobody can stop P1 to close, or P1 to stop its work, or you cannot close P2 to stop its work, because no preemption is possible. And third thing, as you can see, there is a loop here, and R1 is assigned to P1, P1 wants R2, R2 in turn assigned to P2, P2 wants R1. So there is a cycle, and because of this, no chance, neither R1 is released by P1 because it is waiting for R2, nor R2 is released by P2 because it is waiting for R1. So neither R1 is available to P2 nor R2 is available to P1, therefore P1, P2, both of them cannot continue, because for P1 to continue, both R1 R2 are required. For P2 to work, both R1 R2 are required, but in this case each one is having only one, other one is missing, and that missing one is with another process, and that is not ready to live because it is waiting for something which is impossible. So this situation is what we call deadlock. So these four serious conditions: mutual exclusion, hold and wait, non-preemption, circular wait. These four together, when all four are satisfied, only then deadlock can occur. If any one of them is not possible, then no chance of deadlock. So that's it about the deadlock and starvation. Thank you.